Welcome to this FINEBox demo. I'm Peter Larsen from Loudsoft. Let's begin by importing a file from FineMotor. This is a 6-inch woofer that I will import. I just used the default data, which includes the linear excursion Xmax. And now we can see the blue curve is this 6-inch woofer in a 25-liter closed box. There's not too much low frequency. Let's try and tune it a little differently. Something like this seems to work reasonably, but still we don't have too much low frequency. So maybe we should try this driver in a bass reflex instead. So we press here and get a bass reflex curve. Let's just change the volume slightly and the tuning by using the mouse wheel. And now we have a nice response. This display shows the SPL and impedance, but we can also show the voice coil travel or unit displacement. On this scale it's in millimeters, and we can see Xmax linear is given as this dashed line, which is close to 5 millimeters. So we can turn out the volume, and now here we reach about Xmax, and at very low frequencies where the response is dropping anyway, the excursion is going way up. This should normally be filtered by a high-pass filter. Down here we can see that there was only 11.4 watts necessary to produce the Xmax. And let us see what happens at much higher input power. Now I will input 100 watts, and we saw that the curve is displaced much higher. In order to study this in detail, we have another display up here which is in 3D. We can see the response here on the back wall, but we also have a time axis, which is actually log time, that will help us to find out what happens over a long time. Now we can use the digital clock to show us what happens over a long time. Here we can see that already after a little more than 2 minutes, the voice coil temperature is higher than 219 degrees centigrade, which is quite high. And if we let it run for a long time, say 4 hours, the voice coil temperature is up at 257 degrees, which is very high. And therefore you can see that we have almost 6 dB of power compression, and that the curve now has a bump at low frequencies. In this example we have imported a 2-inch neodymium unit from FineMotor. You can see here it's designed with a top magnet. And this is a bass reflex curve. Now we can use an ABR, which is the same as a passive radiator. The ABR can be designed to have the same passband as the bass reflex, but produce less low frequency. Now let's concentrate on the ABR and try an example where we tune differently. We will make the volume larger and then tune the ABR for that. We can tune the resonant frequency of the ABR and also the mass. And here we get a nice extended response. Let us take a look at what happens at higher power. Going back to the excursion, and we can look at the driver that was in the small volume to be a little conservative. Let's try and increase the input so that we come 3-4 dB up, say, to this level here. It is a little higher than before, but not that much. Let's see what happens at this power. We look at the time, the 3D display again, and we can see at maximum time the voice coil is up at 235 degrees. A high power voice coil may survive that, but look at the magnet system. It is at 146 degrees. No neodymium grade can take that. They will demagnetize. So this is serious. And even if we had made this as a car speaker, we could simulate the outside temperature as maybe 50 degrees C, and it would go even worse. In addition to the bass reflex, we have another kind of tuning which is called bandpass because we have the driver sitting between two chambers, and with the resulting response is like a bandpass where it automatically cuts off the high frequencies. There's another variation which is a bandpass with another port in between, and this is even more interesting and can be tuned like we saw before. These configurations are very important when you're working with microspeakers. In this example, we have imported a model from FINEBox, which is a 50mm micro speaker, and we have tuned these small chambers so that we get the blue response, which is a kind of bandpass. You can see that there's a peak here at 4K, and after that the response is dropping. The next curve, the red, is similar but has more extended response, and the resonance here at the high frequency is damped more. This is simulated by simulating the felt in the port with a low Q value.